Alright, in this video I'm going to work the two problems off of the free fall problem set. I'll start with number 2. So number 2, we have a 32-meter tall building. We don't know how fast it's going to be going when it hits the ground. So we have a building, it's 32 meters tall, and we're going to just assume, since it's dropped, that our initial velocity is 0, and we're going to see how fast it's going when it hits the ground. So we're looking for the final velocity. That is our unknown. We know the distance is 32 meters. That's how far it's going to fall. And we know, of course, the acceleration at negative 10 meters per second squared. So when you're doing these problems, you want to really think about what the initial velocity is. It matters a lot in terms of the problem. So if I look at my givens, I look at my formulas, the only one that makes sense to use is this one. Alright, and then you have, you can go ahead and plug in. So this will be final velocity squared. Initial velocity is 0, so I'll just take it out. Equals 2 multiplied by negative 10 meters per second squared multiplied by 32 meters. Alright. Plug all that in, and you get negative 640. So you said VF squared equals negative 640 meters squared per second squared. Now, the last step, of course, is take the square root of this. Now, you can't take the square root of a negative number, so just take the negative out whenever you do it. So, I'll square root both sides, and the final velocity is equal to 25.3. Technically, it's moving down, so that would make it negative. Alright, and so that is how you do number 2. The last one, the other one I picked was number 16. Number 16, you're throwing the ball vertically down. So it's a similar issue, but the initial velocity is not 0. It's being thrown down, and we are trying to see how tall the cliff is. So it's being thrown down. The initial velocity is 8 meters per second. Technically, it's negative 8 meters per second because it's going down. Okay, so if I was writing my givens, my initial velocity would be negative 8 meters per second. My acceleration is given. Well, it's not given, but it's understood. And the time is 6 seconds. And we are looking for the height of the cliff. So D is equal to the unknown. And we know it took 6 seconds to hit the ground. Alright, so if you look at these givens, you have the initial velocity, you have time, you have acceleration, you have distance. So the only equation that makes sense in this case is this one. Right, and the initial velocity, make sure you actually plug it in. It's going to be negative 8. I'm going to leave the units out of this so I can fit it in here. Multiplied by 6 plus 1/2 negative 10 multiplied by 6 squared. Okay, you can plug all of that in. Now be careful with the negative signs. You get negative 228. And the negative here doesn't really mean much in terms of a physical quantity, so you can take it out if you wanted to. So the distance, the height of that is 228 meters.